Okay, let's unpack this. You think about artificial intelligence hitting the absolute core of the real world. I mean, where does it get bigger, faster, and with higher stakes than, like, global finance?
Right. It's hard to imagine. We're talking about systems managing literally trillions of dollars.
Trillions. Split-second decisions impacting markets, the financial well-being of maybe billions of people.
Absolutely. The scale here is just, it's immense. This isn't some theoretical AI research project. It's AI being deployed right at the heart of how global capital flows.
Uh-huh.
The complexity, the precision required, and, the potential impact are just off the charts.
And that is exactly what we're diving into today. We got to look at material detailing how one of the, well, undisputed giants in this space, BlackRock, is not just thinking about AI. They're actively building and deploying production-ready AI agents directly into their central nervous system, the Aladdin platform.
Yeah, and our mission for this deep dive is to really go through their explanation and pull out the crucial nuggets. We want to understand their specific approach, how they're using like agentic architecture and frameworks like LangGraph.
Okay.
And maybe most importantly, how they're tackling that huge challenge of making this system reliable and safe.
Yeah.
I mean, especially when you're dealing with assets measured in trillions.
Right. Because the coolest AI tech in the world is useless or, worse, dangerous, if you can't trust it implicitly, not with $11 trillion under management.
Exactly.
So let's start with the basics. BlackRock. For someone maybe less familiar, what is it and what exactly is Aladdin?
Sure. So at its core, BlackRock is one of the leading global asset managers. You mentioned the scale, over $11 trillion in assets under management.
Mm-hmm.
Their stated purpose is helping people achieve financial well-being. And absolutely critical to that mission is their proprietary technology platform called Aladdin.
Aladdin isn't just their internal trading system there, is it? It sounds bigger than that.
Oh, much bigger. Think of Aladdin as a unified platform covering the entire investment management lifecycle. It's their whole portfolio solution, they call it.
Okay.
Used internally, yes, but also sold and supported for hundreds of clients globally, operating in over 70 countries.
Wow.
Yeah, handles everything from trading and risk management to operations, compliance, you name it.
Wow. So it's this whole ecosystem unto itself. How many people does it take to support a monster system like that?
Well, the Aladdin organization is massive, around 7,000 people total.
7,000.
Yeah, and over 4,000 of those are engineers, maintaining something like 100 different front-end applications that users are interacting with daily.
Okay, 100 different apps. So you have this vast network of engineers, all these applications. Where does AI strategically fit into BlackRock's vision for this massive platform?
They have a very clear, firm-level vision. They see AI as a way to significantly boost everyone's productivity using Aladdin,
Makes sense.
to drive what they call alpha generation, essentially finding ways to generate better returns and to create a much more personalized experience for every single user.
And the specific initiative they're using to bring this vision to life, is there a name for it?
Yep, that's the Aladdin Copilot. And it's designed not as some standalone tool,
Right.
but to be deeply embedded across those 100 existing Aladdin front-end apps.
Ah,
Think of it as like the intelligent connective tissue that proactively helps users and surfaces relevant information right where they are.
got it. So integrated directly into the existing workflows, what are the main goals then, the core value drivers they're building this Copilot around, based on what they said?
They laid out 3 primary goals. First, making every user feel like an Aladdin expert, which means making the platform much more intuitive, easier to navigate, probably through natural language interaction.
So less hunting through menus and clicking around, more just asking the system what you need.
Exactly. The second goal is increasing personalization and customization. By understanding the user and their specific needs, the Copilot can unlock new efficiencies, through highly configurable experiences tailored kind of on the fly.
Okay.
And the third driver is democratizing access to insights.
How so?
Well, with a platform this complex and data-rich, making it significantly easier for users to quickly find the specific data points they need that empowers them to make better, faster decisions.
Yeah, that resonates, making complex systems easier, tailoring them, cutting through the noise to get the insights. Okay, let's get into the engine room. How did they actually build this Aladdin Copilot from an architecture standpoint?
Their approach is fundamentally agentic, meaning they're breaking down complex tasks into smaller steps handled by specialized components or agents that can interact with different parts of the Aladdin ecosystem.
Right, agents.
And a really key piece of this architecture is what they call the plugin registry.
Plug-in registry, what's that doing?
So this is where all those different Aladdin engineering teams, remember the 50, 60 domain-specific teams we mentioned, like trading or compliance?
Yeah, yeah.
This is where they can onboard the functionality they own into the Copilot system.
Ah, okay, so it's like a central catalog or capability store for everything Aladdin can do.
Precisely.
Yeah.
And dev teams have two main ways to expose their capabilities to the Copilot.
Okay.
The first is defining a simple tool, which basically maps one-to-one to an existing Aladdin API that's already in production.
Right, for straightforward stuff.
Exactly. Pulling specific data points, simple actions.
Okay, map existing APIs as tools. What's the second way to plug in?
For more complex workflows, maybe something that requires multiple steps or, more sophisticated logic, teams can spin up an entirely custom agent and plug that into the system.
A custom agent.
Yeah, and this custom agent can then orchestrate its own multi-step processes.
It's fascinating that they started designing this system 2 to 2.5 years ago. That feels pretty early in the recent AI wave. Did they use standard agent protocols from the get-go?
Well, back then, the landscape of AI agent protocols was very different, right? Much less mature than today.
It's true.
So they actually had to develop their own internal standardized agentic communication protocol, a very specific version tailored just for Aladdin.
Wow, okay.
Now, they did note they are actively evaluating newer, more established open source protocols like LangChain's agent protocol and AutoGen, which kind of shows they were early but are also staying current.
That's a significant detail, building their own protocol initially. Okay, let's walk through a user query to see this architecture in action. They use the example. What is my exposure to aerospace in Portfolio 1 at this point in time? How does the system actually process that?
Right. So imagine you're sitting in one of those 100 Aladdin applications, and you type that query in.
Yep.
Crucially, the system doesn't just get the text string. It also gets vital context.
Like-
Which specific app are you in? What data is currently on your screen? Which portfolios, assets, widgets are displayed? What are your global user settings or preferences? All that context goes in with your query.
That context seems absolutely essential for the AI to, understand the user's intent and narrow things down.
It absolutely is. From there, the query enters their core orchestration graph. And they were clear this has been built using LangChain from day one. It's their framework for managing the flow.
LangChain being that popular framework for building LLM apps. Okay, what's the very first stop in this orchestration graph?
The first node is an input guardrail. This is where they handle responsible AI checks right up front.
Okay, like what?
They look for off-topic content, toxic language, and importantly in finance, they identify any potentially sensitive, personally identifiable information, PII, and make sure it's handled with extreme care or, redacted.
Safety and data privacy from the jump makes sense. What happens after the input guardrail?
It moves to a filtering and access control node. Remember that plugin registry with potentially thousands of registered agents and tools?
Yeah, thousands.
This node does a few critical things. First, it applies access control. Are you, the user, even allowed to use this specific tool or agent based on your permissions, the environment, the app you're using?
Right.
Second, and just as critically, it filters down the potential universe of tools the system needs to consider for this specific query.
Why filter? Why not just let the AI see, the whole universe of possibilities?
Performance.
Yeah.
It's a huge factor. They mentioned if they send more than maybe 40 or 50 tools to the next step, the performance really suffers.
Ah, yeah.
So this node intelligently cuts down the list of relevant tools and agents for this query, maybe from thousands down to just 20 or 30, before it goes to the part that actually decides what to do. It dramatically reduces the search space for the AI.
Efficiency is key when you have thousands of potential actions. Got it.
Yep.
Okay, guardrails passed, relevant tools identified. Where does the system figure out the plan?
That happens in the orchestration node itself. This node relies heavily on GPT-4, specifically its function calling capability.
Okay.
That's where the LLM figures out when and how to use those external tools or APIs registered in the system. It enters a kind of planning and action loop.
Explain that loop.
Sure. GPT-4 decides which tool to call based on the querying context, executes it, gets the result back, and then decides the next step. It keeps doing this loop until it determines it has a final answer or confirms it just can't fulfill the request.
It's like a mini project manager, sort of delegating tasks to the right tools.
Exactly. And once the orchestration node determines the final answer based on those tool outputs, it passes through one more layer.
Yeah.
Output guardrail node.
Another one. Why?
This is their attempt to detect hallucinations, made up or incorrect information before the answer gets presented back to the user.
Ah, another critical safety check before showing it to someone managing assets. And finally,
The answer is returned to you. For that example query, what's my aerospace exposure? That might be something clear, like your exposure to the aerospace and defense sector in Portfolio 1 is currently 5%.
that's a very clear journey for a query. Now, you mentioned this production orchestration is built on LangGraph using a supervisor pattern. What does that mean for the architecture practically?
Right. LangGraph is basically a library built on LangChain for creating more stateful, multi-step workflows with LLMs. It's perfect for this kind of orchestration.
Okay.
The supervisor pattern means there's a central controller in this case, the orchestration node driven by the LLM that directs the flow.
So it's in charge.
Yeah, it receives inputs, decides which agent or tool should run next based on the overall plan, passes information between them, maintains the state, that kind of thing. It's different from a purely autonomous agent system where agents might call each other directly without a central arbiter.
Right.
For a high-stakes production environment like this, the supervisor pattern gives you more centralized control. It's often easier to test and manage reliability for, at least initially.
Okay.
And they did note this is their current approach, but they have aspirations for more autonomous agents down the line.
That makes a lot of sense. You'd want tight control over the flow when accuracy is so paramount. Which brings us to maybe the most crucial aspect, reliability. How do you build confidence in a system this complex with so many moving parts and potential failure points, the guardrails, the filtering, the planning, the hallucination checks?
This is where they really hammered home a concept they call evaluation-driven development.
Evaluation-driven development, okay.
They made a direct comparison to test-driven development in traditional software engineering, saying that building systems with LLMs is fundamentally no different when it comes to needing rigorous testing.
Interesting comparison. Tell me more. Where do they start with this evaluation stuff?
They start right at the foundation. The system prompts. These are the instructions given to the large language models, right?
Yeah.
They test every single intended behavior defined in those prompts.
Okay, give me an example. How do they test a behavior from a prompt?
They used a really telling one. Let's say you put in a system prompt. You must never provide investment advice, which is obviously critical in their domain.
Absolutely.
Simply writing that in the prompt is not enough, not even close. To guarantee that behavior, they have to generate vast amounts of synthetic data representing different user queries.
Okay.
Work with subject matter experts to define precisely what investment advice even means in various edge cases. Build an automated evaluation pipeline.
Wow.
And rigorously test that the system never crosses that line.
Wow. They sound incredibly thorough, almost paranoid.
They actually use that word themselves, paranoid, to describe their approach to avoiding critical errors. They explicitly mention not wanting a Chevrolet Bolt type issue,
Yeah.
referencing a major costly product recall.
Right.
They even use other LLMs as judges in their evaluation pipelines to help score whether the system's response actually aligns with the desired behavior defined in the prompts and the ground truth.
Using LLMs to judge LLMs, that's fascinatingly meta. How does all this testing fit into their daily developer workflow? Is it separate?
No, it's integrated directly into their CI/CD pipeline, their continuous integration, continuous deployment system, basically how they automatically build, test, and release code.
Okay.
These comprehensive evaluation reports run daily, sometimes nightly, and critically on every single pull request a developer submits.
Why is integrating it into the CI/CD so impactful? What does that actually do for them?
It enables their thousands of developers to move quickly without breaking the system or degrading its performance.
Oh.
When a developer makes a change, they get immediate automated feedback. The tests tell them if their change introduced a bug, caused a regression, or even subtly reduced the system's correctness or reliability according to their metrics. It's how they prevent themselves from chasing their own tail, as they put it, trying to figure out why some change unexpectedly impacted the LLM behavior down the line.
So that rapid, continuous feedback loop is absolutely non-negotiable for them. Beyond just testing the prompts, how do they test the entire sequence? The orchestration, the agent interactions, all that.
Yeah, they built an extensive end-to-end testing capability specifically for the entire orchestration flow and the interactions between agents, and also between agents and the back-end APIs.
Okay, end to end. And how do they set up those complex scenarios for testing?
They have two layers for this. First, there's the configuration layer.
Configuration layer.
Yep. This is where developers precisely define the test scenario. They can specify the exact Aladdin application the user is supposed to be in, the screen context like what portfolios, assets, widgets are loaded, the user's specific system settings and preferences, and even simulate multi-turn chat history.
So you can test how the system responds to a follow-up question based on what happened before.
Exactly. You recreate the entire user environment context. Then the second layer is the solution layer, which they call the ground truth.
Ah, the ground truth. Is that just the final correct answer, the number it should spit out?
It's much more than that, actually. The developers provide the step-by-step expected solution for how that specific user query in that precise context should be solved by the system.
Step by step.
Yeah, this can include multi-step or even potentially multi-threaded workflows.
Multi-threaded. What does that look like in a ground truth definition?
They gave an example. If a user asks something like, how much of BlackRock stock can I buy in portfolio X? The ground truth might specify a solution that requires 3 separate, maybe independent paths.
Okay.
First, get the current exposure to BlackRock in the portfolio. Second, check compliance rules to determine the maximum allowed position size. And third, check the available cash balance in the portfolio.
I see.
The ground truth defines all these necessary steps and the expected outputs for each step.
So the ground truth isn't just the final number. It validates that the AI's planning and execution process actually followed the correct path using the right tools in the right order.
Precisely. Providing that detailed ground truth is how the core Aladdin Copilot team can guarantee that the orchestration behaves correctly and efficiently, routes queries, no matter which specific agent or tool from the domain teams ends up getting called.
Right.
And these E2E tests, tied to the ground truth, run daily or nightly, and the results get fed back to the domain teams. This helps federate the development of the agent techs. Each team knows exactly how their piece is performing within the larger system.
That's an incredibly rigorous approach to validation. It sounds like a ton of work, but necessary. What did they explicitly state was the single biggest lesson learned from doing all of this?
Their biggest lesson, crystal clear, was that comprehensive end-to-end evaluation, integrated directly into your CI/CD processes, is absolutely non-negotiable for building scalable, reliable AI products in large enterprises.
Non-negotiable.
Yeah. It's the only way to definitively know if your system is improving, if it's deteriorating somewhere, and it provides the necessary confidence to deploy widely and move quickly with changes.
That insight extends far beyond just AI, really. But applying that level of structured testing to the, let's say, less deterministic world of large language models and agents, that adds a whole new dimension of challenge.
It really does. It highlights that for these high-stakes applications, the flashy AI model is only one part of the equation. The surrounding engineering discipline, the robust guardrails, the intelligent filtering, the stateful orchestration patterns, and this absolute obsession with comprehensive automated evaluation, that's what makes it viable and trustworthy for production use at this kind of scale.
So pulling it all together for you listening, we've taken a deep dive into how BlackRock, a titan in global finance, is building and deploying cutting-edge AI agents right into their core Aladdin platform. And the surprising details weren't just about the agent tech itself, cool as it is, but the profound commitment to a structured, almost paranoid development process. We saw their agentic architecture, the plugin registry as a central hub, the careful multi-stage query lifecycle with layers of guardrails and intelligent filtering.
And that critical focus on evaluation-driven development. Rigorous E2E testing with ground truth, all integrated into their CI/CD pipeline.
Exactly. It's really a blueprint for building trust and reliability in AI systems where the cost of error is just astronomical.
It definitely shows that successful AI deployment in critical infrastructure is maybe less about magic models and more about world-class software engineering practices, just applied with renewed intensity to the unique challenges of LLMs and agents.
Which leaves us with this thought for you to consider. As these AI agents become more sophisticated, potentially more autonomous, and more deeply embedded within complex high-value systems like asset management systems, providing critical insights, or even helping execute actions, how does that fundamental challenge of ensuring trust, reliability, and ultimately accountability evolve?
Yeah, what new forms of evaluation, oversight, or maybe even human-in-the-loop mechanisms might be required as these systems grow in capability and influence? Good question to ponder.